We're going to look at examples of a strong acid and a strong base calculation. If we have 25 milliliters of 1.40 mole per liter nitric acid poured into 15 milliliters of a 2 mole per liter solution of sodium hydroxide, what is the pH of the resulting solution? The first thing that we're going to do here is write out the chemical equation of what we're working with. So we have HNO3 aqueous plus sodium hydroxide goes to water and sodium nitrate. The next step is to find my moles of each so that I can determine my limiting reagent. I have 0.025 liters, and I'm going to multiply by 1.4 moles per 1 liter to give me 0.035 moles. For my base, I have 0.015 liters and a concentration of 2.0 mole per liter, giving me 0.030 mole. Now that I have my moles, I can compare them to find my limiting reagent. So I'm going to solve for my moles of nitric acid based on what I have for my sodium hydroxide. For every 1 mole of sodium hydroxide, I have 1 mole of nitric acid. That will give me 0.030 moles. And I can see here that the sodium hydroxide that I used was not enough compared to my original. Not enough NaOH. Therefore, it is the limiting reagent. So when I put in solution my nitric acid and my sodium hydroxide, all of my sodium hydroxide will be used, and I will still have some nitric acid left over. I want to figure out how much is going to be left over. So I'm going to calculate my N left is equal to my excess, so 0.035 moles of HNO3 minus 0.030 moles of sodium hydroxide, but I want to convert this to nitric acid by using my mole ratio. And I'm going to get 0.0050 moles of nitric acid left over. Now that I have my moles left over, I want to calculate my concentration of my hydrogen ions. I know, before I get to that nitric acid only has 1 hydrogen that it gives off. So my concentration for nitric acid is the same for my concentration of hydrogen ions. My concentration is my moles left over from nitric acid divided by my total volume of 0.025 from my nitric acid plus 0.015 from my sodium hydroxide. I have a concentration of 0.13 moles per liter. I notice that I have 2 sig digs here in my question, so my answer for concentration is 2 sig digs. I'm going to use this to find my pH. This is step number 5. We know pH is equal to negative log hydrogen ion concentration. We have negative log 0.13 moles per liter. Since I have 2 sig digs, I know that I'm going to want to respond to my pH in 2 decimal places. My final answer is 0.90. And that is a pH of my strong acid and strong base example.